Hey, this is Dr. Riley, and in this module, we're going to explore some multi-step conversions using molar mass. A separate module introduced the mole and more basic mole calculations. It's extremely useful in chemistry to be able to determine the weight of a number of moles of a substance. The balances in your lab don't measure moles, they measure grams. So in the case of elements or monatomic ions, this is actually as simple as looking at the periodic table. Copper, for instance, has a molar mass of 63.546 grams per mole. Note the units. This is the number of grams per mole. That is the molar mass of elemental copper. Now, a chemical compound of any kind is just a collection of atoms that are bonded together. So to calculate the molar mass of a compound, water, for example, we begin by looking up every component and the number of those atoms that are in each molecule. Then we have to find the molar mass of each component and then sum the masses for all of the atoms present to find the molar mass of the molecule itself. In order to do this, we need to pay special attention to the subscripts. That tells us how many of each atom are present in the molecule. In this case, there are 2 atoms of hydrogen and 1 of oxygen. When there's no subscript, you assume that there is just 1. So in order to conduct the calculation, you need to multiply 2 times 1.0079, and that is 2.0158. And down here, we just have 15.999. The last step is to add these together. They're all found together in the molecule, so the sum of these numbers is 18.015. That's the number of grams per mole, and that is the molar mass of water. Now, water is a delightfully straightforward molecule, but the reality is a lot of molecules you'll be working with in the lab are a lot more complex. EDTA is a common additive in shampoos, and I use it all the time to capture ions in solutions in lab experiments. Its complex structure is shown right here. That's a single molecule of EDTA. Now, I just taught you how to add up the mass of every single atom in a molecule to obtain its molar mass. But because this is an enormous molecule, that would take you quite a while. You could do it, but there are usually better ways with larger molecules. 2 typical shortcuts are that you'll either have access to the chemical in the research lab, and the molar mass of chemicals is written right on the bottle by the manufacturer. Or, in the case of practice problems like this, it may be provided for you. The trick is to look at the question and identify the place where they're labeling something with the correct unit, grams per mole. Your eye will quickly go to the conversion, and you'll realize you do not have to take the time to add up the molar mass yourself. Huge time savings. So let's look at the question here. How many grams of EDTA are in that many moles of EDTA? I recently performed this experiment in the lab, and it required me to measure out this many moles. But as you remember, hopefully, you can't use a balance in the lab to measure out moles. You have to measure things out in grams, which is why we need to do this conversion in the first place. So you simply start by writing out the number of moles, 0.020 moles of EDTA, and we're going to do in a single step the conversion between moles and grams. Now, whether you put the conversion in the numerator or the denominator depends on the units. I actually start these calculations by putting the units in first, personally, so I know I can cancel them in the end. So now I know I need to go from moles to grams. 1 mole of EDTA is 292.24 grams. Now all that's left is multiplying this through. To be able to weigh this out, I would need to measure 5.8 grams of EDTA in my lab, and that is the equivalent of 0.020 moles. I want to note that I rounded my answer to include only 2 significant figures. I was limited in the question by the measurement provided by the question itself to these 2 sig figs. Don't forget to consider sig figs every time you're doing one of these calculations, because you're doing calculations that are pertaining to measurements. There's a separate module that will discuss significant figures in great detail if you're interested in that. Now let's flip that type of calculation around. Are you able to calculate moles from mass? If you weigh out 49 grams of EDTA, 49 grams, how many moles are you weighing out? Same exact approach. And if you're using units in how you write out your calculation, you're not going to mess this up. We're going from grams to moles using our molar mass. So going up here, I knew I needed grams in the denominator, so I can eventually cancel those out. 292.24 grams are in 1 mole of EDTA. Now I just need to do my division, and it turns out that 49 grams is the equivalent of 0.17 moles of EDTA. Another thing to note when you're doing these calculations is it's very useful to identify not only the unit of measurement, but also what you're measuring. I wrote down EDTA because different molecules have different molar masses. It's always better to err on the side of being too detailed in chemistry. Now we're ready to try one of these multi-step mole calculations together. Imagine that you're curious how many atoms of helium are in a balloon. I looked this up the other day, and a helium balloon contains about 0.0088 grams of helium. That's something that you could easily measure in the lab. So let's do the calculation to figure out how many atoms of elemental helium are in that tiny balloon. Just as in the single-step calculation, we're going to be starting with the known information. We have 0.0088 grams of helium provided for us. According to the periodic table, the molar mass of helium is 4.0026 grams per mole. So this will take us from grams into moles. I'm going to go ahead and put the units into the calculation first. So we know that there are 4.0026 grams per mole of helium. But I didn't ask how many moles there were, I asked how many atoms there were. We've already used the molar mass. The other thing that we need to use is Avogadro's number in our multi-step calculation. So to get to the number of atoms, we know that 1 mole of helium is 6.022 times 10 to the 23rd atoms of helium. So now we're set. Let's just cancel our units to make sure we've set this up correctly. And we need to multiply through. When we conduct the arithmetic, it gives us a number of 1.3 times 10 to the 21st atoms of helium. Woo, that's a lot of atoms of helium in a single balloon.